Hello everyone, so let's discuss about the module 2 runoff. The syllabus includes the components of runoff, methods of estimation of runoff, infiltration indices, hydrograph analysis, unit hydrograph, its assumptions and some problems related to unit hydrograph and hydrograph. So runoff, when rainfall falls onto the landscape, it seeps into the ground to refresh groundwater, but most of it flows down gradient as surface runoff. Runoff is an intricate part of the natural water cycle. So runoff is often defined as the portion of rainfall, snowmelt or irrigation water that runs over the soil surface towards the stream. The figure shows the process of runoff. In this you can see the surface after infiltration, the excess water will flow over the ground and reach the stream. And in the case of snow, the runoff will be less compared to the rainfall. Now this is the graph that shows the measurement of this runoff, and the graph is called hydrograph. Okay, in the x-axis it has the time duration, and in the y-axis it has discharge, and it is measured in m³ per second. The discharge is measured in a device that is installed in the river, and the variation of the flow of the river will give you the measurement of runoff. So why hydrograph? It is to find out the discharge pattern of a particular drainage basin. It helps predict flooding events, thereafter influence implementation of flood prevention measures. Now hydrograph theory. So this is a hydrological cycle figure. So here you can see after the precipitation, what happened is some of the water will go down as infiltration, and it is a percolation and interflow takes place, and some of it after infiltration goes down as surface runoff and reaches the stream. Okay, this is the hydrological cycle figure. Then hydrograph is a graphical representation of time versus discharge at a particular point on a stream or channel which drains the watershed area. In this figure shows the components of a hydrograph. It has a hydrograph that shows the rainfall. After the rainfall, what happened is, if we measure the discharge in a river, we can see that there will be an increase in the discharge of the river, and it reaches a peak value and then it falls down. And this is yellow color shows the base flow, that is the water that is already present in the river. The x-axis is for the duration and y-axis is for runoff. Hydrograph is a graph showing the rate of flow versus time past a specific point in a river or other channel or conduit carrying flow. It can also refer to a graph showing the volume of water reaching a particular outfall. Then we will be able to manage the stormwater, identify the flood plains on downstream, to place the hydraulic structure at safe level. Hydraulic structures are dams, canals, weirs. So for the construction of all the hydraulic structure, we need the flood prediction of that particular area. Then design the different types of hydraulic cycle, minimize the effect of flood. So in this figure you can see this is the center of the hydrograph and this is the center of the hydrograph, and lag time, you can see that it is the time duration between the center of the hydrograph and center of the hydrograph. So that in practical it is the time taken for the water from the time taken for the water that has fallen at the farthest point of a catchment to reach the stream. So what are the essential components of hydrograph? It is the rising limb, it is the crest segment and the recession limb. And it has a base flow. The base flow gives the flow that is already present in the river. Base flow separation. When you separate the base flow from the hydrograph, you will get the measurement of only the direct surface flow. And